The goal of this project is to integrate security scanning using Trivy into a CI/CD pipeline to ensure the only safe applications are deployed. In this workflow, the system automatically builds a Docker image from the source code and scans it for vulnerability. If any critical issues are detected, the pipeline will immediately fail and stop the deployment process. On the other hand, if the image passes the security test, it will be deployed to an EC2 server. This approach helps developers catch security problems early and introduce a strong DevSecOps mindset where security is integrated directly into the development and deployment process. System flow explanation. The process begins when a developer pushes code to a GitHub repository, which triggers a GitHub action pipeline. The pipeline first builds a Docker image from the application source code. Next, Trivy scans the image to detect vulnerabilities, acting as a security gate. If the image is safe, it is pushed to Docker Hub as a central registry. After that, the system connects to a remote EC2 server via SSA with the latest image and run it as a Docker container. Once the container is running on a port 3000, users can access the application through the EC2 public IP address using a web browser. Demo flow. In this demo, we assume that the EC2 instances is already prepared with Docker installed and security port configured to allow port 22 for SSA and 3000 for application access. The next step is to configure GitHub secrets to securely store credentials such as Docker Hub username and token, as well as EC2 connect detail. After that, we modify the application code and push the chain into the repository. This action automatically triggers the CI/CD pipeline. Once the pipeline finished successfully, we open a browser and access the application using the EC2 public IP and port 3000 to verify that the deployment is working correctly. Demo app. The demo application is a simple Node.js service running inside a Docker container. It listens on port 3000 and returns a basic message like hello from secure CI/CD when accessed. Although the application is very simple, it is enough to demonstrate the full CI/CD process, including building, scanning, pushing, and deploying. This makes it easy to understand the workflow while still reflecting how real-world systems operate. In this slide, we focus on how to build a secure Docker image when working with the Docker. Many developers only care about making the application run. However, in real-world systems, especially in production, security is equally important. There are three key best practices we should always follow. First, we should use a lightweight-based image, such as on-prem. For example, instead of using a full Ubuntu image, we use Node 20 on-prem. This helps reduce the image size and, more importantly, reduce the attack surface. Fewer packages mean fewer potential vulnerability. Second, we should install only production dependencies. In development, we may use many tools like testing libraries or debugging packages, but in production, these are not needed. By installing only production packages, we make the image smaller, faster, and more secure. Third, we should never run the container as root. By default, many containers run as the root user, which is dangerous. If an attacker gains access, they could control the entire system. So instead, we use user node. This ensures the application runs with limited permission. The main goal here is very important. We want to reduce vulnerability before scanning. Instead of fixing hundreds of issues later, we prevent them from happening in the first place. Project objectives. Why this project? Now let's understand the purpose of this project. In traditional development, security is often checked at the very end. This is risky and inefficient. In this project, we introduce a DevSecOps approach, where security is integrated into the pipeline from the beginning. Here's what our system does automatically. First, it builds a Docker image from our application. Next, it scans the image using Trivy, which is a popular security scanner. Then comes the more important part. If critical vulnerabilities are found, the pipeline will fail immediately. If no critical issues are found, the image is considered safe and can be deployed. This creates a strong rule. Unsafe images are blocked. Only safe images are deployed. This is what we call a security gate. The key idea is that security is not optional anymore. It becomes a required step before deployment. This mindset is the foundation of DevSecOps. Let's start tool use. In this project, we use a simple but powerful set of tools. First, for CI/CD, we use GitHub Action. It allows us to automate the entire pipeline directly from our repository. Next, we use Docker to package our application into a container. This ensures consistency across environments, development, testing, and production. For security, we use Trivy. It scans Docker images and detects vulnerabilities such as outdated library or no CVEs. We also use Docker Hub as our container registry. This is where we store the distribute our Docker image. Finally, we deploy the application into AWS EC2 instances. This simulates a real production environment in the cloud. Together, these tools create a complete pipeline from code to containers to security scan to deployment. Project structure. Simple structure. Let's take a look at the project structure. This structure is intentionally simple. The app folder contains our application code. The Docker file defines how we build our container image. Inside GitHub workflows, we have the CI/CD YAML file. This is where we define our CI/CD pipeline. We also have a Trivy init file. This allows us to init specific vulnerabilities if needed. For example, if a vulnerability is known but not relevant to our use case, the key idea here is simplicity. Even with a small structure, we can build a production-ready pipeline. This makes the process easy to understand, maintain, and scale. CI/CD pipeline step. Now let's walk through the CI/CD pipeline. Everything starts when a developer pushes code to GitHub. Step 1, the pipeline tests out the source code. Step 2, it builds the Docker image using the Docker file. Step 3, it installs Trivy, the security scanning tool. Step 4, it scans the Docker image for vulnerability. Step 5, it uploads the scan report for visibility and auditing. Step 6, if the scan passes, it pushes the image to Docker Hub. Step 7, finally, it deploys the image to AWS EC2. The entire process is fully automated. This means no manual step, no human error, faster and more reliable deployments. This is the power of CI/CD combined with security. Security gate, Trivy scan. Now we come to the more important concept of security gate. We use the following command: Trivy image. Let's break this down. Security critical means we only care about the most serious vulnerability. Access code 1 means if any critical issue is found, the command will return an error. And in CI/CD pipeline, an error means the pipeline fails immediately. So the behavior is very clear. If critical vulnerabilities are found, pipeline stops. If no critical issue, pipeline continue. This creates a strong enforcement mechanism. Security is no longer just a report. It becomes a decision point. This is why we can't hit a gate. Nothing passes through unless it is safe. Thank you.